Tell me the answer. No. What are the fields? I think you people have forgot. Huh? What are the fields in communication? I think in this slide we don't have. Okay, tell me what are the fields we have?
Serial communication, ma'am.
Yeah, serial communication only I'm asking. What are the bits will be available? Start bit, what ma?
Stop bit, ma'am.
Start bit, stop bit, then
Mm,
start bit followed by data bit, parity bit, stop bit. Only four field. We already seen in first 8051 serial communication, and while I'm starting about this unit also, I have specified. So start bit will be there. Yesterday I have shown one video for you now. There the group of bits transmitted from DTE to DCE. What is DTE? What is DTE, ma? DTE. I think the people you are not listening. I am asking very simple questions to you. What is DTE? In RS 232, what is DTE?
Data terminal equipment, ma'am.
Very good, very good. Data, Bhavana, very good. Data terminal equipment. DCE,
Data computer equipment, ma'am.
our communication equipment, we used to say. Data terminal equipment is computer. Data communication equipment is our modem, printer, and all we will specify. But normally, while communicating that, so you understand that in my UART field, I think you have to remember this. Okay, one start bit will be there, then stop bit will be there, then data bit will be there, then parity bit will be there. So this is the structure for UART. In UART, we will write like this: start bit, data bit, parity bit, stop bit. But you all understand, CAN is a separate protocol, so we can't able to use the same serial communication concept here. So what they did now, they developed their own message frame for CAN. So you have seen, these are my bits of message frame. So you all understand, start frame, end of the frame will be there. Okay, arbitration and control field all will be also there. So arbitration is nothing but, yesterday I told you, one or two controls will there. I have to take which control as a primary one. That is arbitration, or else that will judge. CAN controller will judge and it will give the priority, and it will accept their own ECU unit. Okay. Then data field. Definitely the data has to be transmitted. So data field. CRC, cycle redundancy check. It is also equivalent to error detecting bit. Then acknowledgement bit. So you all understand, in my in my CAN controller, I need this much. So UART or RS232 also following UART communication. So only this much of bits available: start bit, stop bit, data bit, parity bit. But here you took up the CAN controller. We have a start frame, end of the frame. Okay, arbitration field should be there. Okay, control field should be there. Then data field, cycle redundancy check field, acknowledgement field. Okay, and now we will see. I think this I have explained. Basic CAN and full CAN and all. So basic CAN means, I told you, it will be used only the body, car body only. But when I go for full CAN, it will be used in the powertrain and all. So both will be used in automation industry, but the bits per second and cost will be vary from basic CAN to full CAN. So you have seen, this is my uh, um, basic CAN. Okay, where the car industry is using. Okay, you have seen that door, sunroof, airbag, driver seat, climate condition, radio, rear and all, rear mirror and all you can see. And but this is the full CAN. This is mainly used in I told you all bullet trains, metro trains, and all power trains and all, they will use the full can. So basic can, full can differ by cost, differ by the rate of speed. So it is greater than 250 kilobit per second now. Sorry, ma'am. This is greater than 250 kilobit second now. This is greater than 125 kilobit per second. Are you clear? Okay. Now we will directly, and I think till this we have discussed what is the standard can frame structure we have. So you all, how you have to remember UART na, start bit, data bit, parity bit, stop bit. Only we have a 4 field is there. But here you have seen that nearly we have a 8 fields there. Okay. So start of the frame, then end of the frame. Okay. And then standard identifier will be there. Okay. And data bit will be there. And this all take as a error as well as acknowledgement, cycle redundancy check and acknowledgement. Okay. And this is nothing but a remote transmission request as well as control bit. So totally we have a 8 field for that. So you have to draw this diagram. Yesterday that only I have specified. While you are asked about any CAN protocol, definitely you have to specify the diagram. So in between that, the 16, 2, 7, 6, 1, 11, 1 and all, the number of bits allocated to the particular field. Okay. So you can understand that my data can transmit 64 bits. But when you take RS-32, we can transmit 8 or 9 bits maximum. But here it can transfer 64 bits. So I told you that can we have a can logging facilities also there. I can save it in my SD card, or I can interface and I can save it in my personal computer. Okay. Now, according to data format, I told you can frame have a this much of field. So in this much of field, I can specify have a two types: standard can and extended can. Standard can means I have a 11-bit identifier. Extended can means I am having a 29-bit identifier. Okay, 29-bit identifier. Okay, now yeah. So please go through this diagram. We have a, standard can as well as extended can message frame. So both the message frame are similar only, but only one thing is different here. I'm having 11-bit identifier and here I'm having 29-bit identifier. So while developing, first they developed only 11-bit identifier, and finally they move on to 29-bit. So the remaining and all same. So SOF means what, ma? What is SOF? What is SOF?
The single dominant start of the frame.
Start of frame. That is the meaning. SOF means what, ma? Start of frame. EOF, na? EOF. I can say, ma.
End of frame.
End of frame. Very good. Then okay. Then we are moving on to this is my data bit. 8 bytes data. 8 bytes now. How many data I told you? 8 into 8, 64 bits data I can transmit. So here also I can transmit 64 bits data. Okay. And then CRC. What is CRC? What is CRC, ma? Cycle. I think you have started
Redundancy check, ma'am.
cycle redundancy check. This bit particular bit allocated for cycle redundancy check. ACK. ACK. Always ACK. Acknowledgement. So you have seen that here we have a handshake signal inside the message frame. In RS-232 communication, in the message frame we don't have any acknowledgement signal. In the pin itself we have a data terminal ready, data set ready, ready to send, clear to send and all available in the pin only. But here in my message frame itself I have a acknowledgement bit. Are you clear, ma'am? Okay. DLC. What is DLC? Data length code. Okay, that is DLC. Okay, IDE. IDE means what? Single identifier extension. Okay, so you all have to identify the identifier. I will explain you. Single identifier expansion. Then RTR. RTR means what? Remote transmission request. So all these are there. So only the difference between the standard CAN and extended CAN is we are having 11-bit identifier and here having 29-bit identifier, 11 plus 80. Okay, then finally we have IFS, interframe space. Okay, so we will see all this bit what we are doing. Same, both the diagrams are same only, ma. But here, what is the difference between the previous one and this now? This I am allocating 11 bit now. They are consisting of 11 bit. Are you clear? So they have allocated with the bit. That is, so if this diagram is convenient, you can refer this. Okay, both are same diagram only. Identifier bit, end of the frame, interframe spacing, cycle redundancy check, acknowledgement, data length code, identifier code, remote transmission request. All this have contained both standard and extended data frame. Okay. Now you can see that what is all this field will be there. SOF. SOF means how I am specifying starting the bit now. This is starting the frame, not a bit, because we are having nearly some 150 bits of data in a single frame. So we have a starting the frame. Identifier. Identifier is nothing but is to establish a priority of the message. Okay, so lower the binary, na higher the priority. For example, yesterday I told you, if you didn't put out the seat belt, definitely what it will do, it will indicate the message. Okay, the seat belt is not on. You are not connected with the seat belt. If the power window is not closed, even though your AC is on, so that much of priority message will be there. RTR means remote transmission request. So you all know it's when you considered that all the nodes request will be received by the CAN controller and it will respond only to the particular node only. So that is RTR, a single remote transmission request. CAN controller will have a two only, CAN low, CAN high. So one it will receive, another it will transmit. At the time, more than one or three nodes will be there. This identifier determines the specified node and then it will respond to that particular one. Okay, IDE means I told you single identifier extension will be there. So this is reserved bit. It will be mainly used for the further standard development. Okay, and now we have seen in automobile industries they have done so many development there. Yesterday I told you automated reverse parking. You need not to touch the steering. The car itself, the controller itself identifier what will be the length lead, what will be the breadth need, and whether the car can be accompanied in that. So it will go and park the car. Okay, so and one more thing, now to avoid the accident and all, we have some distance is needed between one vehicle to another vehicle. If you on that particular mode, the car will maintain that particular distance between your vehicles. So even that we have so many way of protection in our car. Okay, so data length code, DLC, and I told you cycle redundancy check. So you always understand that whether my data should be transmitted without any error. If any error is there, that will be identified by this cycle redundancy check. Okay, that what it will do now, parity now, what we will do, ma? Parity check means what? What is parity check? What is parity check?
Check whether the same bits are available.
Mm, check with same bit are available.
That means if the data was correct or not.
Parity means it will identify how many odd number of ones are there, how many even number of ones are there. That is parity check bit. For example, you are transferring some 4 ones means that is even parity. If you are transferring 3 ones now, that is odd parity. That will be checked by parity bit. So cycle redundancy na it will check the sum error. Can you understand? Okay. ACK, acknowledgement. So the acknowledgement they have sent that whether I have received the message. If any over messages are coming, I have received my previous acknowledgement, then a new message I am receiving now, that will be automatically override by the ACK. EOF, end of the frame. I have completed my work and all, that will be denoted by the end of the frame. It's a 7-bit frame. Okay, then IFS. IFS means I told you interframe space. It is nothing but whether the controller is moving correctly, whether it is received the frame, whether the some message will be in the buffer. So whether it is responding to correctly, the particular frame will be checked. That is interframe space. Then SRR, substitute remote request. Okay, it is nothing but RTR will be replaced by SRR. Then I told you single identifier extension, that is for only extended CAN. Okay, and additional reserved bit is there, R1. DLC means data length code. So you all understand, you have to remember this field very well. Start of the frame, end of the frame, then interframe space will be there. Okay, and then data length code, data bit, identifier, remote transmission request. This is single remote request. Okay, so both are same, only thing is put 11 bit and 29 bit, that is the difference. Okay, so you have to this is one of the important topic in CAN. I told you that this CAN RS432, how they will ask the question now. Explain in detail about the CAN protocol and all, only the question will be there. So you always have to be prepared how to write CAN question in 16 mark. Okay, that is the way you have to think and write. Okay, now I told you CAN have three important part. CAN transceiver, that means it will do transmission as well as receiving. CAN high, CAN low. Okay, the two bus will be there. One is for receiving and another for transmitting. So CAN bus will be there. Then transmission, receiver. The entire thing will be under the CAN controller. So CAN controller, what it having now? Message frame, error, everything. The message frame will be in the CAN controller. When I take the microcontroller, my programming, my microcontroller, whether it may be 8051 or DSP microcontroller or PIC controller and all, will be available in the CAN. Okay, so you have four types of frame. We have seen the message frame, but normally we will classify into four types. What are the four types now? Data frame, it will transmit the information. Remote frame, it will request the information. Error frame, it will identify the error. Overload frame, so that indicates more time required to process the message. So there will be that I want to process more than one now, that will be under overload frame. So data frame will transmit, remote frame will receive, error frame will identify the error, and overload frame take more time to process the message. Okay, so this have they have written how they have identified in the field, and they have written in this. Okay, and another one is CAN node. I already told, in computer network we have a 7 layer that will not change. Physical layer will be there. Then we have a logic level layer, network layer, transport layer, session layer, presentation layer, application layer. So these are the 7 layers in computer network. We all know CAN is also one of the protocol mainly to transmit the information. So, but the CAN only deal with 2 layers only. One is physical layer and another one is data link layer. So it won't touch the network transport session and all that remaining layer. Why I have drawn that now? On that day I have specified. While I want to interconnect any computer, or I want to interconnect the mobile, or I want to interconnect my embedded network, all these 7 layers are very, very important. According to the computer standards, they developed the 7 layers. Physical layer, logic link layer, network layer, transport layer, session layer, presentation layer, application layer. So my CAN protocol is in physical and data link layer. Okay, are you clear, ma'am? Okay, physical layer. Physical layer means you all understand that there my CAN transceiver, CAN bus line will be there. So all my electrical specification, connecting the cable and all will be in the physical layer. But while it comes to the data link layer, we have a framing, error checking, error identifying will be in that. Another one is data link layer. So data link layer, first I have to know about the message, errors and all. And another logic level is nothing but data transfer, receiving the data, storing the data is in buffer. All this will comes under the logic link layer. So you have to identify that my CAN protocol is influence only in the two layers. One is physical layer and another one is data link layer. They told another last one is nothing but application layer. Application layer means they use the controller, whether it may be a microcontroller or ARM controller or PIC microcontroller or DSP controller, any controller they can specify in the application layer. So it will influence only physical layer and data link layer. Okay, physical layer always the specifications, physical connectivity, cables will all comes into the physical layer. But when you move on to data link layer, automatically medium access control and logic link control will comes under the data link layer. Okay, and this I have told you how we were connecting the CAN bus. So we have only two lines, CAN low, CAN high. You all see this is a impedance which will connected with that, and CAN transceiver, CAN controller, any controller, microcontroller or DSP controller will be used. This is the connection, how they were connecting through the microcontroller to the CAN bus and all. Okay, so we have a different channels. Through the channels, I think you have a the image which that CAN controller sensors. Sensors will play a very much important role. So that from sensor to CAN controller, CAN controller to CAN transceiver receiver. Through that, we will connect it with the CAN bus. CAN bus, we have a two lines, CAN high and CAN low. And arbitration, I told you, arbitration is nothing but priority or judgment will comes into the picture. So what is the why now I will receive too many messages, but I have to avoid the collision. So that is the arbitration field. So carrier sends multiple access with collision detector, that it will do by arbitration field. Identify which will be more priority. If engine failure or brake failure comes, then automatically if there is any problem on for example, you have some light inside the car is glowing, at the same time there is a anti-braking system is not working now, we definitely give attention to ABS system. So similarly the CAN controller will give the priority, and it will identify which is the maximum priority message. Through that only the CAN controller give the attention. You have seen node C is transmitting, node B is transmitting. So here it will identify, okay, node C wins arbitration. That means node C have a high priority. And while coming here, node B wins, that means node B have the high priority. So the particular bit is node is wins means CAN bus will take that control. Okay. So please listen, ma. I will tell you how to write as a 16 mark question for this CAN. So first you write about what is CAN. This diagram is enough. Okay. One is transmitting, another one is receiving, another one is ignoring. So that you have to do. Transmitting means CAN low, receiving means CAN high. Okay. Then who is developed the CAN? Some introduction. Then before CAN, after CAN. This diagram is very important. The importance of CAN. Okay. So before CAN, after CAN diagram. Then next one is, this diagram is not necessary. CAN applications. You can remember two or three applications and write. This is CAN advantages and the future of CAN. Then three types of CAN controller. Okay, that I have to explain. Then CAN frame. Actually, this diagram is not necessary. What I have explained, everything is combined here. Okay. What are the message frame? I told you now, this is important thing. And you have to do what are the two type of CAN, full CAN and basic CAN. Actually you explain this too. If you remember, you draw this diagram. Okay, then what this diagram is very important, the standard message CAN frame. Okay, then you have to draw this diagram, standard CAN and extended CAN, both the diagram will be same, but here you have to identify 29 bit. This is not necessary. If you draw this, don't draw this. Okay, then you have to explain the field. Then what are the four types of frames are available? Data frame, remote frame, error frame, and overload frame. Okay, and then this diagram is necessary, or else you draw any one diagram. Okay, because you have to know my CAN is influencing on the network layers and all. It's very important. That why you are specifying. Then this diagram. Okay, this is not necessary for your understanding purpose. I have drawn. Then what is arbitration? That also you have to explain it. It's clear? Okay, actually, yesterday you have. Can you able to view your scores, ma?
Yes, ma'am.
Yeah. Okay. Register number one. Aarti. Aarti have scored good. Aarti is good. Jagan. Jagan. Are you here, Jagan? 82. Register number 82. Who is 82, ma? Sneha. Sneha. Good. 92. Um, Varsha. Good. 37. Vijayshri. Jayshri. I'm sorry. Jayshri only, na? Always Jayshri will take good marks, ma. Jayshri. Consistently she is taking. And 97. 97. Who is 97? Oh, you people will go done a 64. Pranjit Das. Okay, good. Register number 14. Bharat. Good. Register number 74. Subrata. Good. Register number 2, Abhirami. Good. Okay, I think 2, 3 and all. So maximum mostly got 10. But my expectation is the last part has to be reduced. Still, some of them got 0, 0. I don't know why. Till 11 o'clock, the score is there. 70. See, only one question is correct. Why and all? Can you able to see this, ma? Can you able to see the Kagot answers?
Yes, ma'am.
Yeah.
Yes, ma'am.
I have asked a very simple question. You read out which of the following can provide hardware handshaking. Handshaking means definitely you know protocol, serial protocol, parallel port, counter, timer won't do any handshaking. Only RS-232. Okay. What lines are utilized during the enable state of hardware flow in control DTE and DCE devices of RS-232? DTE means what, ma? Bhavana said DTE, data terminal equipment, DCE, data communication equipment. You all understand we have a 9 pins in RS-32. CD, carrier detector. Okay, this is ring indicator. DSR, data set ready. DTR, data terminal ready. You have to that. I want to ready to send or clear to send and all. Only these 2 bits only enable the data flow. So DTS, sorry, CTS and RTS. What is UART? Very simple question. Universal asynchronous receiver transmitter. How many times I have repeated that? Which protocol standard of serial communication specifies the half duplex? We all know RS 440, 485 only half duplex. RS 232 is what, ma? What kind of communication? RS
Full
232.
duplex, ma'am.
Very good. Full duplex. RS 485 is half duplex. What is the maximum device handling capacity of serial standard protocol RS 485 in terms of drivers and receivers? How many, ma'am?
32, ma'am.
32. It's very important. 32. I told you for RS-232, how many drivers and receivers needed, ma? RS-232? Anyone can tell? For RS-4485, I need maximum 32 devices. For RS-232, maximum?
16.
No man, one. Only one driver and one receiver is. I think you people have telling the random answers. Less than RS 485. Huh? While difference itself, I told you one driver and one receiver because it is full duplex. Okay. But here we have a half duplex. So I have to transmit, I have to receive. So for that, we need a 32 drivers and 32 receivers. Okay. Which company developed RS-232? EIA. Okay. EIA have developed that. Okay. Electronic Institution Association. In RS-232 communication, all data bits are sent and held for a constant period of time. Time won't change. How it is tending? Because we are RS-232. இல்ல ma'am. சரி சரி. You all understand? RS-232 will transmit at what speed, ma'am? What speed? Tell me what speed? What speed it is transmitting, ma'am? No one? RS-232 will transmit at what speed? Aruna Devi? No one.
Ma'am,
What answer for that?
I don't know, ma'am.
What is 20 kilobit per second? I told you. RS-485 is 100 kilobit per second. So the transmission speed will not change. So it's a constant period of time. Are you clear? I have to show you the difference also. RS-232, RS-449, RS-532, all are examples of connecting the terminals and modem, DTE and DCE. Okay, the remaining and all not a thing. Okay. A smart modem accepted commands from terminals via RS-232 interface. That will be the smart modem. Smart modem. Okay. Which of the following can be used for long communication? You see, actually you didn't study this and all. I2C, SPI and all you are seeing not studied. But RS-232 is having maximum length. What is the maximum length, ma? What is the maximum length? RS-232.
15 meters.
50, 50 feet. RS-485?
4,000.
Yeah, 4,000 feet. But when you take the other serial communication, you know, we have seen CAN and all, and so it will be used on automobile industries and all. Maximum the CAN length will be a limited only. But when you take RS-485, we can use up to 4,000 feet. RS-232 up to 50 feet. More than that feet, if I used, definitely I have faced with the problem. I thought I got uh, see, in this fourth unit we have completed distributed embedded system, embedded networking also completed, RS-232, RS-485 completed, controller area network completed. So the remaining topic is I2C, SPI, USB, Ethernet. Okay, only 1, 2, 3, 4. 4 topics only available there. I have asked one question. No one is replying. Difference in RS-232. This table I have put. How many, ma? One driver and one receiver. And here how many driver? 32 driver, 32 receiver. Maximum cable length, 50 feet. You all understand? The RS cable only we have a maximum length. I2C, SPI, CAN, and all the length will be limited only. Are you clear? And 50 feet, 4,000 feet. What is the maximum data rate? 20 kilobit per second, and this is 100 kilobit per second. And one more thing you have to remember here will be my signal level of voltage is plus or minus 25 volt, and here it is plus or minus 6 volt. That is the only thing. Okay, ma. Now you people, I have allotted some seminars to some of the students. Okay, I think Bhavan, are you ready?
Yes, ma'am.
Okay, shall I share your
Yes, ma'am.
yeah. Everyone listen to her. See, you want to write a assignment also, you are supposed to know. I think Saranya having lot of problem. Yeah, start ma.
Yes, ma'am. Hi, friends. Good morning. Today I'm going to take about application of microcontroller in 8051 obstacle avoidance robotic vehicle. Next slide, ma'am. Components which are used in obstacle robotic vehicles are battery, diode, 8051 microcontroller, ultrasonic sensor, motor driver, and motors. Ma'am, the robotic vehicle is used for transportation without driver, and this robotic project is designed to detect and avoid the obstacles on
9:30
the
yeah.
robotic vehicle path.
9:13 then.
Ma'am,
Ah. Okay. You continue, Bhavana.
next slide, ma'am.
Uh, hello, Bhavana. Yeah, you speak, ma.
Slide, ma'am.
Oh, next
Next.
slide you are asking. Okay. Uh, mm, yeah.
The ultrasonic sensor is interfaced with the 8051 microcontroller, and if any obstacle signal is sensed by the ultrasonic sensor is given to the microcontroller, then the microcontroller generate the output signal. After that, the output signal is fed to the motor driver. Based on the signals received from the motor driver, the motor can change the direction like left, right, forward, or backward of the robotic vehicle to avoid the obstacles. Then the speed of the motor can controlled by the pulse width modulation technique. Thank you, ma'am.
Yeah, good, Bhavana. Good. Actually, Saranya is facing the problem. Wait, ma. Okay, I will enable. Okay. So listen, ma. She have taken a wonderful topic, Bhavana. Actually, this ultrasonic sensor in car and all, we have some reverse parking, and now we have in advanced version we have a display also. Along we can able to see what is happening. Every time we have to look up at the mirror and all, not necessary. So ultrasonic sensor will always detect the motion. Actually, how far we there is there any obstacle is there or any other thing is identified. I think she have taken ultrasonic sensor as a input and motor driver. This program I have already explained you. Did you remember? The motor will rotate in clockwise and anti-clockwise. So she have explained to identify the obstacle. So ultrasonic sensor, the another application we were using in the car and all, mainly in automobile, in the reverse parking of car, we were using this ultrasonic sensor. Very good, Bhavana. Yeah. The next one, Avinash. Avinash, are you ready? Or else you take leave. Avinash, where mom? No, Avinash is not there today. Yeah. Hey, what happened? I asked Avinash, he take leave. I asked Balashankar, he also taken leave. I asked Bharat, he also taken leave. Very good boys. Hey, this is thing you have some exposure, so you all taken leave. Very good. And yesterday, I think Mogana Priya, whether your connectivity is now correct? Mogana Priya is there.
Ma'am.
Yeah, can you able to take now? No puzzle. Directly go on and explain. Mogana
Okay, ma'am.
Priya, yes.
Okay.
Uh, Yeah, who is having? Abhiram is having your PPT. Yeah.
No, ma'am. I am only having, ma'am.
Okay. Can you able to share?
1 minute, ma'am. Yes, ma'am.
Okay, I will give authority. Yeah, now you can share. Directly go to block diagram. Ma.
Going to see is infrared TV. This is the block diagram. I can
Your voice is not
TSOP,
continuously audible.
controller, transistor, relay, and
Moganapriya. 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 Yes, ma. Moganapriya, what you will do? Tomorrow you send the PPT to me. Are you clear? Tomorrow we will check it. Okay. Next one. I told you that next batch. You people don't have a guts final year. I'm just asking in real time. Nandini M, are you here? 57, register number 57. Nandini M.
Yes, ma'am.
Okay. Tomorrow will you take?
Yes,
Or else
ma'am.
today you are willing?
Tomorrow.
Tomorrow. 58 Nandini R. 58 Nandini R.
Ma'am,
I will you take today or tomorrow?
ma'am, yesterday I taken, ma'am.
You have only taken. I thought 56 Nandini. Okay. 56 Nandini. Register number 56. Okay. If you are not taking now, I thought okay. Neetu Priya.
Ma'am?
Tomorrow will you take?
Yes, ma'am.
Okay. So Nilofer. 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 She went. Pandyarajan. Tomorrow will you take Pandyarajan? No, ma'am. Yes, ma'am. So many network problem. Tomorrow you prepare and come. Then we will decide. If you can't able to share, send to my mail ID ma pushpavalli.triply@satyabama.ac.in.
Okay, ma'am.
Okay. Then Parameshwari.
Yes, ma'am.
Pandirajan is tomorrow will take. Okay. Parameshwari.
Okay.
Parameshwari is there.
Okay, ma'am.
Parameshwari.
Ma'am? Ma'am.
Will you take ma tomorrow?
Yes, ma'am.
Okay. So I have allocated for 56 Nandini M, 57 Nandini M, then Neetu Priya, Nilofer, Pandirajan and Parameshwari. Okay. Don't take leave ma. If I ask you to take a seminar, see All the guys, Avinash, Balashankar, Bharat, all taken leave. Oh my God, that much of afraid to take seminar. People, have you posted Mogana Priya? What will you send? Will you send me? I will explain your because you have a problem. You have done lot of effort, but still you having a network issue. Or else tomorrow we try. Yes. See, remember students, tomorrow I will take first hour class, not last hour. First hour class. So be prepared on first hour itself. Are you clear? Tomorrow my hour is changed to first hour. So I think tomorrow also first hour only. So be prepared and come.
Ma'am,
Yeah, what ma?
shall I take tomorrow?
Yeah. Vijay Shri, you have there, no? You take
Yeah.
Vijay Shri. You can
Yes.
able to share.
Tomorrow I'll take, ma'am.
Tomorrow you'll take okay, Vijay Shri. So tomorrow so many students are there. Okay. That's why it completed today by 9:10. 20 minutes is there, at least 4 people can take. All the students have taken leave very cleverly. Okay, I will read out who are all absent. 53, 54, 55, 56, all are present. 57, 58, 59, 60 is absent. Okay, 61, 62, 63. Okay, 69. See, students, have anyone completed? You those who have given the seminar, you can able to submit your assignment. Can you understand or not? So try for that. I told you, don't wait till I will allocate. I will announce only the day before. So you be prepared. Don't take leave for that and all. It's a, while you are explaining your part 5 question, draw the block diagram and explain in a paragraph. That's it enough. Okay. So I will read out the absent, who are all absent to the class. Register number 5, Akashing. Register number 9, Anurag. Then 12, 13, 14. Then 16, 17. 16 is absent only, na? 16, 17. Then another absent is our register number 30.
17 present, ma'am.
17, Bibu Anand present. Yeah. Okay. I have read out the names now. Register number 30. Then 91. Sorry, 48, 50, 52, 60, 64, 67, 91. Then Sagli Vijay Kumar. So all these students were absent. So people by used to identify what are all the things available in embedded controller application. Yesterday I told you I gave 96 now. So nearly we have seen some uh, 11 students have taken the seminar till now. Okay, so each and every students have taken one thing. Abhirami have explained about how to. She has only started the seminar. So what she have explained now, by knowing the passcode only you can able to enter into the any buildings and all. She have explained well. So each and every student, one of the students electronic voting machine and Angeline traffic light controller explained. Magalakshmi, you have explained the iPhone processor and all. So then Anshuri Subramaniam have taken home automation, how ARM7 controller are used. So in different journal, the people were explaining so many things and all. And today, Bhavana she explained ultrasonic sensor. Actually, she have explained in detecting in a motion. But when you see that ultrasonic sensor, I think if possible, actually you can if one day what I will do, I will allow you to explain one online tool. In that, obviously what happened now, so many things is open, so I can't able to open anything. Actually, she have taken very good topic. Ultrasonic sensor is one of the important application. So you see in there ultrasonic sensor. So this is the ultrasonic sensor image ma. Okay. So when you go with the ultrasonic sensor, we have a supply, ground, trigger, and echo. Only these four knobs. So that supply and ground has to there. So it will identify always the object which is in which meter. Normally the ultrasonic sensor can capable to locate 10 meter, 20 meter, 30 meter and all. We were getting the distance now. Sometimes which is very close to the obstacle, it will show stop. So the way ultrasonic sensor. So one time, if the time permits, one day I have a online that is using one microcontroller. We can able to develop the program and we can able to connect through the hardware components like breadboard, how to connect the ultrasonic sensor with the Arduino controller, and we have to embed the program and all. So what I have explained in your lab also, you have same software like Proteus. If most of them were taking the diagram from there only. Proteus software. Along with that, we were writing the assembly language code we have to write. Are you clear, ma? So people kindly make use of it. Don't take leave and all. If you can't able to take or you have some network problem, I will accept. So Mogana Priya, you will send me the PPT to me. Tomorrow I will share. If you can't able to speak, I will speak in your voice. Okay, it's not a big problem because you have done a lot of effort to prepare. So don't take leave. Some of the students were taking the leave for not taking the seminar. Don't do that. You give some reasons or else you try it. I told you one the best way, prepare 3 slides. You can't able to speak fluently, you just write it and read it out. That is enough, because you are not going to teach in presence, but it will give a confidence for you. When you give one answer, you will be happy on knowing the answer. So taking some seminar for 5 minutes now, knowledge sharing, you can understand. And while you are searching in net, you can understand what are the various applications are there. So to explore your knowledge only I gave this. To taking 5 minutes is not a big thing. And tomorrow we will see the another serial protocol, I2C. What is I2C, ma? What is I2C?
Inter-integrated circuits.
Very good. Inter-integrated circuits. So that we will see tomorrow. So far we have seen only two protocols: RS-232, RS-485, and another one is CAN protocol. Okay. Eduthiru sir. Ma'am, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. ஆமா, ஒரே ஒரு நிமிஷம் வெரிஃபை பண்ணிக்கிறேன். 2, 15 பேர் தான் சார். Yes, ma. I think ma'am came. I will leave the meeting, ma. So tomorrow I allocated for so many students. So I will be coming first. Remember, I2C. I will complete that and I will do. So I think next week we will complete the fourth unit. Probably we will complete in next week. Is clear, ma'am? Okay. Kavita ma'am, வந்துட்டீங்களா?